In this video, we're going to focus on text cleaning with string functions. So we're on to chapter 3, and so we need to move on to the chapter 3's Jupyter Notebook, and that's really cool. And so what we're going to do is let's first look at what chapter 3 is about, and then we'll move on right into working with spelling mistakes and typos in text data. So we've finally got a decent subset of data after watching our awesome chapter 2, but none of the individual values make sense, right? So on the overall, you're liking what you're seeing in the subsets of the data, but then within individual data points, you have problems you need to fix. So how do you untangle multiple pieces of information, deal with missing data points, and parse different strings? And here's how. So the first thing we need to do is to prepare ourselves for this course. And so for here, we're importing pandas as PD, as we've explained, and also importing NumPy as NP. So how do we work with spelling mistakes and typos in text data? Well, first we need to understand how we can work with text data. To illustrate this, let's create a series, a pandas series. And in 9, in the first line, what we're going to do is assign a pandas series into the variable s, okay? So s is going to be a series. And in this series, we have 9 values, of which 8 values are strings, and the last one is not a number or an NA, and that's represented by numpy.nan, np.nan. And so we have sort of like a real world series where we have some data and with some missing data, and that's stored in S, okay? To work with text data in pandas, that is very easy. So we look at our next example here in 11. In the first line, we're simply working with all the string data by passing in s.str, which is short for string, as you know from Python. And we can call any sort of string function that we're familiar with in Python already, and it will work in our series. So here, the example that I've given you is s.str.lower, and that takes the string values of this series and transforms them all into lowercase. And so if you look at the difference between out 9 and out 11, you can see that each element is transformed into all lowercase across all the characters, and you can see that the NaN is smoothly processed and no problems were raised. Conversely, we can again do upper, which is another function in string. So what we can do is s.str.upper, and what happens here is we basically take each of the strings of the series and transforms it into uppercase. Again, as you can see, all 9 values gets transformed correctly. The not a number or the NA in the pandas series doesn't get affected, doesn't raise an error, and is very smooth. Another example is in 13. So in 13, we call a slightly different function. So instead of transforming the string, we actually operate on the string itself. And so what happens is we are looking at the length of the string, and we see that each string in the series is successfully converted to its length, and again, length is something you would use on normal strings as well. You can also see that the outputting series is converted from an object D type, as you can see here in out 12, into a float 64 D type that is shown here in out 13. So a common use case of this is to clean up the column names. So one of the recent examples that I've dealt with is somebody gave me a data frame that is imported from an Excel sheet that really isn't very nice. So one of the issues there is the column names are all over the place. First of all, there are too many spaces on either side of the column names, and second of all, the column names just don't look like something you're going to use in pandas or in a respectable programming environment. So what I really want to do is to take all of these guys in a lowercase, take away the spare spaces, and transform the middle space between first name and last name into underscore, so it resembles more the way I look at Python variables. So here, let's create a dummy data frame where we create just 2 columns, 5 rows, random numbers from Renan, very standard. The columns are first name and last name. As you can see, there are some naughty bits of spaces here. There's 1 space on the left, 1 space on the right that is really not needed. First name and last name are both capital cased, and we do not want the space in the middle. So if we look at this and we chain some of the functions that we know from Python's string library into the str objects, we can do all of this very quickly. So what we do here is we first take the columns, we access the string value by doing df.columns.str, we strip the spaces from either side, so we call the strip call, and then this actually returns an append series, so we can't just chain more string functions to it. Instead, what we need to do is again access the string function str and then call lower, which transforms all the column names to a lowercase, and then replace the middle space with an underscore, and out comes something that we like and love. So obviously we can't just have an index object that we like and call it a day, so what we need to do is to assign the outputs of this string of string functions into df.column. And there we have it in out19, nice and easy. What we can also do is we can create a series of lists. So here we have pd.series, and in each of the elements we have a string that comprises of some characters and some underscores, and if we call the string function and split function, we can create a series of lists. We can access each individual element again by the string function, and here what we're doing is we call pd.series and we take the list of underscore separated characters, we split it by the string, split it by the underscore, and we get the first item. We can turn these lists into columns. So in in24, what we're doing here is we are first taking the same list, we're splitting it by the underscore, but here we have a new parameter called expand equals true. What this really does is transforms the series into a data frame. In each element there's a series ABC, CAE, and FAA. And so by calling string, we can then access the replace function, which is the same replace function Python uses, and we can feed it a regular expression pattern that it then evaluates and use this to replace things. So here we're only replacing an A into 6x's if the A starts at the elements and not anywhere else, and we also want to ignore the case. So here we only replace one thing. However, we can also turn off regular expressions. So here we again create a PD series. We feed in a list of underscore separated characters, and we replace A with a caret here into 6x's, but in this case we disable the regular expression. And so the result of this, of what happens here, is it would then ignore the fact that this is a special command in the regular expression world, and it would just simply match the string. It can't find that string and nothing happens. The next section we're going to work on a new problem, which is predicting disease progression. I'll see you guys in the next video.